Hi and welcome back. So in the previous video we have learned how to handle our RSA service, but in this video we will learn how to work with the hash functions. In case you don't know what the hash is, actually hash is a sign, somehow some sign of a text or a file or a byte array or whatever that you're going to use. Each file, if you do not modify it, for example an image, if you don't modify it, its hash always would be the same. So for example, you have JPEG or a movie, something, or with a specific size, and you want to check the hash. It means that you want to check the signature if this file is being modified. For example, you want to encrypt a file and send it to your friends. In case you want to check that this file is not being decrypted somehow, some sniffers, some hackers doing it, and modify it, then you will actually use the hash function to check if the hash that I've sent you before is the same that these files contains. So it means that if you hash an object, it will return an array of bytes, and you always have the same hash for the same file if you do not modify it. So before actually make you confused, let me explain with codes. So let's go to the crypto session and create the function for get hash service. It's going to get a function. So it means there are some ways of actually hashing a file or an object. We will have three type of them here, and using this enum class hash functions, we will return the hash service. So let's create this enum class. Enum class hash functions will have SHA-256. It might be very familiar for you guys. It's one of the most common hash functionality, and SHA-512 and MD5 are three of most popular that I'll teach you how to use it. And then let's create the package called hash, and inside it let's create the interface called hashService, and we will return the hash service based on that. So let's create three implementation class. First one is going to be MD5 hash, which is going to implement hash service, and we will copy and paste it using SHA-256 hash, and again SHA-512 hash. So these are three implementation of our hash service using this functionality. So let's go to our concrete class of our crypto session and implement them here. So in case of each function, we will return when the function. Now it's time to add remaining branches. So in case of SHA-256, we'll return the SHA-256 hash class. Same goes for here, and also for MD5 we will return MD5 hash class. Simple as that. So let's start creating actually these hash functions from top to bottom. So let me close other tabs and go to the hash service. So inside the hash service we will have three functions, three overloaded functions. So the first one is string input, and we'll return the byte array. The next one would be the same name but with inputs of byte array, and it will return the byte array. And the last one, which is the suspend function that we are going to use, it's for the file, and it also returns the byte array. So these are three functions that we are going to use in each hash concrete class. So let's go to the MD5. So first function to handle is going to be this one, which is the main function. So we will create a digest of MessageDigest of Java security and get instance and pass MD5 to it. This is the algorithm name. And then return digest.digest.input. So like this, we will hash this byte array and create a new byte array of this. So to hash a string, we simply return the hash function that has the byte array as input and pass input to byte array. Simple as that. And for the file, we will create the digest of type MessageDigest and get the MD5 instance. And then we will create an input stream to read the file. So let's use file input stream and create file input stream and pass the file to it. And we'll pick a buffer of type 8K. Buffer is going to be a new byte array of type 8192, and bytes read is equal to file input stream dot read and pass the buffer to it. So we will check if the byte that we read before is not equal to -1, it means we have something that this buffer contains. So let's update the digest and pass the buffer to it from index of 0, and how much it's read is equal to bytes read. And then read the next part using bytes read is equal to file input stream, and then read the next part and pass buffer to it. And right after this while loop, we will close the input stream and then call digest on our digest object. But this is a suspend function, so I forgot to start it using with context and dispatchers.io. So right here, we will return the digest.digest, which is a byte array that we need. Perfect. So let's move to the SHA-256 hash. Well, this is exactly same as actually MD5 hash class. So I'll copy and paste, but the algorithm is going to be SHA-256, just like that. And I'll copy and paste it for SHA-512 as well. And the algorithm is going to be SHA-512, just like that. Okay, so it's time to test our functionality. Let's go to the main activity and get the hash service first. Private val hash service is equal to hash service is equal to session get hash service. And for the hash function, we will pass, let's go MD5. We will test everything here. Okay, so we will actually use this hash function. And down here on click, we simply want to use the launcher here again, file picker launcher, and pass it to our button, file picker launcher. Let's change it. And we want to launch to open everything so we can hash everything we want. So in case of launching it, we will open a URI, get the file name as we did before, and create the file to encrypt. So let me remove the extra part here. So the file or the peaked file is here. So using peaked file, we'll first check if it's not null. We will use this as the name of non-null file and open a coroutine block using dispatcher.main, and we know it's going to switch to IO. So right here, using HashService, we will hash our file, and let's use it hash the file. And also I want to create a text to hash, some random text to hash, and hash this one as well. It's equal to HashService and hash this one. So let's log this to hashed file is equal to hashed file, and let's make it to list so we will be able to see what's inside this. And same goes for hash text, using hash text and convert it to list. So if we run our application right now and copy this log, so let's copy it here. So let's choose a file first. Let's use this image.jpg. You'll see this is the hash array of the file, and this is the hash array of the text. So I've told you before, if we do not modify this text, the hashByteArray of this file and this text should be exact same. So let's use it again, and you'll see every byte in this array are exact same as these two. So if I check this file first, for example, you will see they are just with the different name. So the file are the same. So you will see the file are exactly the same, but the names are different. These are the files that I've used to encrypt and decrypt again. So you will see the hash of these files are exactly same. Let's actually test it like this. You will see if I pick any of this, the hash of them is exactly same. But these are the files that I have used to encrypt and decrypt before. Okay, so right now let's change the functionality to SHA-256 and run it back again. So let's hash them again. You'll see the size of the hash is bigger, which means our signature is very stronger right now. And if I check for the other files, I don't know, this one and this one, you'll see the hash is going to remain the same. So let's move it to SHA-512 and check the hash again. You'll see the size of the hash array is bigger now, and it's all the same for the other images. So that's how you can hash an object in cryptography world. Okay, so that's pretty much it for this video, and till the next video, see you everyone.